Good afternoon, folks. Some of you may not have made it to the to one of the last sections of the 2.6 unit, which deals with the topics of left and right continuity. Depending on when you printed this out, this number right here might have changed, but this is the topic of left and right continuity, and also depending when you printed out, this entire section may not have shown up. But I want to go ahead and discuss the topic now. So we've got an interesting graph over here on the right where we have some discontinuities. The function is not continuous at -1, it's not continuous at 0, it's not continuous at 1. It's also not continuous at 2. How come? Because the limit proper at 2 doesn't exist. Notice the left-hand limit at 2 exists, but the right-hand limit does not. And that actually gets to the heart of what we want to discuss in this section. So we're going to say that f is left continuous at x equals 2. So I'm saying that the function is left continuous at this point right here. How come? Well, because f of 2 exists, and to be continuous, the functional value has to exist. And the left-hand limit, that is, as x approaches 2 from the left, we see that the y values are approaching 5. So as x approaches 2 from the left, the y values are approaching 5, and so the left-hand limit is 5. And notice that these two values agree with one another. So even though the right-hand limit doesn't exist, or the right-hand limit might be something other than 5, the left-hand limit and the functional value agree here. And if that's the case, then we're going to say that we're left continuous. Okay. Further, we're going to say that f is what? Well, f is right continuous in many locations, but specifically I want to say that f is right continuous at x equals 1. How come? Because f of 1 exists. What is f of 1? F of 1 is 4, so i.e. f of 1 equals 4. And the right-hand limit, the limit as x approaches 1 from the right of f of x. See here, we approach 1 from the right. Let me pick a different color here. Let's approach 1 from the right. What are our y values doing? They appear to be getting closer and closer to 4. As our x values approach 1, our y values appear to be approaching 4. And so we would say that this, oops, that's the wrong size, that these values here are approaching 4. Notice that the functional value exists and it agrees with the right-hand limit. When that's the case, we'll say that we're right continuous. Notice that that means that if, for instance, if I'm saying that this function is continuous at x equals -1/2, when I say it's continuous, notice it's both left and right continuous at that location. Okay. Also, we could notice that f is not continuous at x equals -1, nor at x equals 0. So here's a question for you. Let's go ahead and list. This is different than giving a domain, right, where we give the set. I want you to list the intervals for which f is continuous, and the answer to this is, well, from -1 to 0 we're continuous, and again from 0 to 1 we're continuous. That part shouldn't surprise you. What's new to the notation is that I'm going to go ahead and put a bracket around 1 and a bracket around 2. When I put this bracket around 1 here, I don't mean that it's continuous at 1. We mean that it is right continuous at x equals 1. We mean that it is left continuous at x equals 2, and regular continuous, that's trying to fight with me, and regular continuous on the interior of those two, of that interval. Okay? So when I list an interval for which it's continuous, I'm going to go ahead and include endpoints if it's appropriately left or right continuous. Be a little bit careful here. When I include the right endpoint, I am not saying that the function is right continuous. I am saying that it's left continuous, meaning the limit as we approach 2 from the left of f of x is 5, and that agrees with the functional value. So that's why we are left continuous at the right endpoint of 2, and we are right continuous at the left endpoint of 1. So now you can go ahead and answer a few of these questions. I'd like to do A and B with you, and I'll leave you to do C and D on your own. So if I'm going to simply list the intervals for which this function is continuous, it's continuous on -∞ to 2, union, I'm listing, so I don't want to use the union symbol. I'm simply going to use the comma to separate the elements in the list, comma, 2 to 3, comma, 3 to infinity. Now, you can infer where this is not continuous by looking at, okay, we didn't include 2 in any of these intervals. Yep, we've got a discontinuity there. And we've got a problem going on at 3. Yep, sure enough, there's a discontinuity here. But notice that I included this 3 in the interval, in this final interval here. I included the left endpoint of 3. Why did I include the left endpoint of 3? Because the function is right continuous at x equals 3. What do I mean by that? I mean that f of 3 exists, which it's 2, and the limit as x approaches 3 from the right of f of x is equal to 2, and these two agree. That's why I'm saying that we are right continuous at x equals 3. Notice I'm not continuous at 3, but when I list the interval for which it's continuous, I go ahead and put a bracket there to signify the right continuity. Okay, so let's go ahead and do B now, and then it'll be the last one. So this is continuous on the interval from minus infinity. You may have a hard time seeing those tick marks. Let me put them on there. It's a little easier to see in case your printer didn't show it. We're continuous from negative infinity to negative 1, comma, negative 1 to 0, comma, 0 to 1, comma, then 1 to 2, and I am I am left continuous at 2, meaning the left-hand limit exists and it agrees with the functional value at 2, comma, and then again from 2 to infinity. Here I mean that I am left continuous at x equals 2. For all other values in any one of these intervals, for instance, maybe the value negative 5, or over here in this interval we could have, say, 0.5, I mean that we are continuous in the original definition sense. But when I talk about the endpoints of intervals, if I put a bracket there, I mean either right or left continuous, as it would be denoted by the endpoint. Okay, I'll let you try these remaining two. Let me know if you have any questions.